Hello and welcome to Module 1 of Mechanics of Materials Part 1. Today's learning outcomes are to describe the importance of studying this topic of mechanics of materials, to outline the general analysis approach we'll take in the course, and to list the major topics in the course. So let's begin by reminding ourselves what engineering mechanics or engineering science is. And I've talked about this before. We start with math, physics, and basic science, or how the physical world works, and then the engineering mechanics, engineering science coursework takes us and bridges us to applications in engineering, mechanical engineering, civil engineering, perhaps aerospace or material science engineering, or any engineering discipline field. And so that's an application of the science to fulfill a human need. Okay, and looking at engineering mechanics, we started with the assumption that we were working with rigid bodies. In my first two courses, we looked at static equilibrium, and we had the courses Introduction to Engineering Mechanics and Applications in Engineering Mechanics. And then later, we looked at those rigid bodies undergoing motion in dynamics courses, and we looked at two-dimensional dynamics and three-dimensional dynamics. And in this course, we're now going to change our assumption. Instead of working with rigid bodies, we're going to say that these bodies can deform. And this is our Mechanics of Materials course. So this is the general analysis approach that we'll take in the course. Mechanics of Materials is the foundation for all structural and machine design. And so we start with some engineering structure, whether it be as large as a building or a dam or as small as a part in a mechanical device. And then we're going to apply some external loading to it. And that loading may take the form of axial forces or torsional or twisting loads, perhaps bending loads, or some combination of all of those loads. And those are going to create internal forces and moments in our structural member. And we're going to look at something which we're going to define as stress and strains. And finally, we'll look at the structural performance based on that analysis. And by structural performance, I mean, is my structure, for instance, maybe deforming or deflecting too much? Is it meeting our specifications in that regard? Is it yielding? Is there a possibility of fracture? Ultimately, we want to make sure that our engineering structure is performing successful and not failing. And so in this course, we have a number of fundamental topics that we're going to go through. And you can see that we start with stresses and strains. And again, in this first course, Mechanics of Materials Part 1, we're going to focus on axial loading. Then we look at mechanical behavior of materials. And finally, towards the end of the course, we start looking at factors of safety, allowable stresses and strains, and we'll look at some cases of axial loading for non-linear behavior, what we call statically indeterminate structures, and thermal and pre-strain effects. That will be the end of this Part 1 course as far as fundamentals is concerned. And then my second course, Mechanics of Materials Part 2, will look at torsional type loads and thin-walled pressure vessels. And then we'll go on to beam bending in the third course in the four-part series. And then finally, in the last part, we'll look at beam curvature, we'll look at beam deflections, again, statically indeterminate beams, column buckling, some more advanced topics. And so my emphasis throughout these courses will be on understanding the principles of mechanics of materials rather than extensive computational or computer work. Obviously, computers and computational programs and software are used a lot in these types of problems, but I want you to have a strong foundation and understanding of the concepts. And so let's get started.